Okay, let's look at 31 through, let's see, up to 36, I think, is all the normal distribution stuff. So we'll look at that in this video. Oh, this is something else. Let's go ahead and add a page. There we go. Okay, so it says 31, let x be a normal distribution with the given mean and standard deviation. Find the indicated probability. So it says that mu is equal to 31, right? This is the mean. Our standard deviation is equal to 20. And we have the probability between 30 and 43. So in the case of this, and they're letting you use your calculator, this is kind of all the information we need. We have an upper bound, we have a lower bound, we have our standard deviation, we have our mu. So this lets us solve. So let's go ahead. We'll open up our calculator over here. I believe it's going to be in second vars for distribution. We are interested in normal CDF. We have a upper of or a lower first of 30. We have a upper of 43. We have a mu of 31 and a standard deviation of 20. Paste. And so we'll just write, and they probably want to see this. I'll have to go back to it. Normal CDF. Let's see that order one more time. Oh, this is right in the way for me. So it says lower bound, upper bound, your mu, and your standard deviation. And so our answer here is, and we want 4 decimal places, so we have 2.457. 0.2457. Okay, 32. It says let z be the standard normal distribution. So this immediately tells us when we read this statement that mu is equal to 0 and our standard deviation is equal to 1. Find the indicated probability, right? So again, it gives you an upper and a lower. So probability of negative 0.82 and z is 1.2. So we have an upper, lower, standard deviation, same idea, and a mean. So let's just go plug it in. Let's go ahead and clear. Second vars, normal PDF. We have between 2 spaces, so in this case we have negative 0.82. We have 1.2. We have mu is 1. Nope, sorry. Clear that. Mu is 0. Standard deviation is 1. And we'll write that down as well. Our answer is 0.6788. 0.6788. And this was normal CDF, negative 0.82, 1.2, 0, 1. Okay, and we'll keep moving. 33. So it says for questions 33 through 35, first find the corresponding z values by hand, and then you may use your calculator or z table. Okay, so it wants us to find the z values, and so all we need to know is the z-score value is equal to the x value that you're interested in minus your mu all over your standard deviation. This gives a way to normalize the results here, so we can just look at our z-scores. Okay, so SAT scores are normally distributed with a mean of 500, a standard deviation of 100. It says find the probability that a randomly chosen test taker will score below 450. So below, x is less than or equal to 450. So in our case, right, z is going to be equal to 450 minus 500 all over your standard deviation of 100. And so we have negative 50 over 100, or negative 0.5. But I still think we want to just use we're still going to use a z-score here. Or I mean, we're still going to use normal CDF in our lower bound. So this is our upper bound, but our lower bound here, well, test scores, your lowest bound is going to be 0, right? It says 450 or below. So let's go ahead and go back. So it just wants the z-score by hand, but we can use our calculator to actually find the probability itself. So second vars, normal CDF, a lower bound is 0, upper bound is 450, our mean is 500, and our standard deviation is 100. And so in our case, right, we have let's go back, 0.3085 is our probability here. And again, I typed in normal CDF, lower bound, upper bound, mean, and standard deviation. Cool. And 34. So it wants still the z-scores here, right? So it still wants us to find these z-scores. Now, using the information in question 33, what is the probability that a randomly chosen test taker will score between 400 to 550? Okay. And so I guess it wants the z-scores associated with these two. Oh, I see. We can do it that way as well. Okay, we'll do it that way since make it a little bit interesting. So same mean and standard deviation. So now our first one is 400 minus 500 all over 100. So we have negative 1. Our next one is z is equal to 550 minus 500 all over 100. So we have 0.5. So we could type, right, using the 400 and the 550 into normal CDF, but we can also use the z-scores, and maybe that's what he's trying to show here, is that once you find your z-scores, right, you can use the standard normal, right, meaning your mu is equal to 0, standard deviation is equal to 1, and now you can use your z-scores, right, the probability that your z value is going to be between negative 1 and 0.5. But if you wanted to do that, you could. I don't see, he's not saying this is not an option in the review, that if you wanted to do mu is equal to 500, standard deviation is equal to 100, and you want the probability between 400 and 550, it's not saying this is an issue either. So, I mean, they'll both get you the same answer. So, just got to type in the standard normal one. Right, they're both the same, though standard normal one is just the normalized version of it. So second, vars, normal CDF, a lower is going to be negative 1, upper is going to be 0.5, standard normal, so 0 and 1, and we'll paste. And so our answer here is I keep doing that, 0.5328. This was 34. Just verifying, yep, 0.5328. And so just to note really quick, right, you could have typed in either of these, right? So I guess I should write it up here. Normal CDF, lower bound, upper bound, mean, standard deviation, or you could have typed in this and they would get you the same thing. Lower bound, upper bound, mean, and standard deviation, right? Both would get you the same value, so either works. Okay, let's do 35. Says, using the information in question 33, what is the probability that a randomly chosen test taker will score above 600? And so we'll talk about this, but it just wants the z-score first. So z is equal to 600 minus your mean, which was 500, all over your standard deviation, which is 100, or in other words, 100 over 100, or 1. Right, so let's use the standard normal. Right, so in this case, we need to be careful because our normal distribution right now, let's say if this is our mean of 500, and we plug in, we have our 600 value over here. Well, if I do normal CDF, it's going to give me everything to the left. And this is everything less than. So what I'm going to have to do is, well, I want the complement, so 1 minus the normal CDF of, and again, you can use either of the options, right? You could use lower bound 600 or 0, upper bound 600, mean 500, standard deviation 100. This is an option. If you want to put the normal or the standard normal, sorry, you could have done, in that case, it's a little bit different, right? For our lower bound, you need that like 1e to the negative 99. So maybe it might be easy to plug in the first one. 1, comma, 0, comma, 1. Okay, so let's do clear. We're going to do second vars, normal CDF. We still want lower bound to be 0. We have upper bound is 600. Nope. 600. Mean is 500. It keeps doing that. 500, and our standard deviation is 100. And we have 0.8413, right? But that's not our actual answer, right? We want to do 1 minus this because we want everything that's greater than that. 0.8413 is everything less than. And so we get 0.1587. Let's verify. Yep, perfect. And let's do one more, 36. And that'll take care of all of the normal distribution problems. Let's see, 36. Suppose that x is a normal random variable with a mean of 100 and a standard deviation of 10. Find a such that, so probability of a such that, right, if we have x between this, it's going to be equal to 0.3. Okay, and so the way that we want to talk about this is we want to look at these two bounds separately. Right, so let's look at our upper bound first, 100. Well, this is actually a really nice number to work with because it's our mean, right? So I actually don't even need to type this into our calculator. I know if I have the CDF of 100 here, right? So let's just say normal CDF. What that is getting me is the area underneath that curve to the left of 100, right? I'm just going to put in 100. I'll put in, what are these? Doesn't say what these are, so we'll just say a lower bound of the plugged in number. It's supposed to be like a negative infinity, but this is what it's using as a negative infinity. 100, right, to 100 mean, and 10, what you'll see is this is going to come out with 0.5. Right, and that makes sense. This is half of our information is hanging out over here in our left side, right, if 100 is in the dead center. And it's saying that according to this, right? Well, it's saying that between A and 100, there is, right, so this is saying 0.5 is over here, right? And it's saying between these two bounds is 0.3. Well, then this tells us that the area to the left of A, right, well, this has to make sense, right? This has to be 0.2, right? Because I know the entire half of it is supposed to be equal to 0.5. So what I'm really looking at is, right, what value, and I don't think we want to use, we're looking, I'll have to look on the calculator to remind you, we're looking for some value here that -1e99, comma A, I don't know what it is, 100, standard deviation of 10 gets us a 0.2. And so I think there's a nice function in here though. Let's see in our calculator. Let's find out. Let's see, well, clear, it's got to be under second vars, I would guess. And it should be the InvNorm, yeah, InvNorm is what we're looking at. And now the area is the same for those who've taken calculus. The area is the same as the area under the curve, or the probability is the same as the area under the curve, right? So in this case, 0.2. Our mu here is going to be still 100. Our standard deviation is 10. And so we have 91.58. And I think some people who have the updated version, it might ask you for a tail. In this case, we're looking at the left tail. Right, so this tells me my A value is 91.58. So just so we have the calculator call right, it was not normal CDF, but I was just giving you the same idea. InvNorm of 0.2, 100 for the mean, and 10 for the standard deviation. And this got you 91.58. And I'll go ahead and verify. 91, that's not right. Okay. Let's try that again. Maybe I typed it in wrong. Let's try. It should be 99.25, so unless I typed in something. Let's see. I don't spot it immediately. What was the standard deviation? Let's make sure I didn't mess up any of the things. Standard deviation. Let's try it again. Double check to make sure didn't make any mistakes here. InvNorm 0.2 is the area. Our mean is 100. Our standard deviation is 0.03. I can't read. So your question, I'm sorry guys. This is, let me move this out of the way. Give me 1 second, I'm having an issue with the video editor here. Let's just do this. Okay, so I can't, I apparently cannot read the problem. This is not, I would be right if we did it that way. This is 0.03. This is how the problem says it, which means this number is actually not 0.2, right? It should be 0.47, and now we'll have the right answer. So not mathematically wrong, just reading. So now when we plug this in, right, we don't want to plug in 0.2. We want to plug in 0.47. So be careful with that. I made the mistake for you. And so now let's try that again. Can I go up? There we go. 0.477. And now we have the right answer. 99.25. Okay. Fix the error there. All right. Well, I will see you in the next video. Looks like we just have 37 through 40, and I did not forget about the other previous problems I skipped over. See you then.